Hi everybody, this is Mr. Yeoman again, and today what I want to talk about is population, and more importantly, how do humans impact the population of other individuals? So the first thing that we need to look at is what types of things control a population. There are lots of extrinsic factors that can affect population, like predators, disease, weather. All these things can decrease the ability of a population to survive. But in a lot of situations, those factors are a result of the population itself. So, for example, if you already have a large population, you're probably at greater risk of having more predators because they have more food to feed off of, so they have more young. And so, really, if there weren't as many members of that population, then the predators wouldn't have as large of a population either. Disease is another one that we get a lot of, that because there are so many individuals within a population, then diseases start spreading through those populations very, very easily just because there are so many members and they're all in a single location. Population growth increases density and may cause food shortages or spread disease. This is a major problem in a lot of places because if you get more and more individuals that live in a location, they start using those natural resources faster. A lot of times, these types of things will keep the populations in check better than anything else. There aren't usually intrinsic factors, so we've been listing extrinsic factors, but intrinsic factors are pretty rare. So one of the few examples of a population kind of keeping itself in check would be wolf packs. Because only the alpha male and alpha female are the ones who breed. So since they're the only members of the pack that breed, then the numbers stay relatively low. So that is one of the few examples of intrinsic factors keeping populations in check. So everything that I mentioned so far applies to all populations, but humans are kind of a different story. Even though we are subject to the same laws of nature that other animals have, so things like epidemics and weather, we try to break those laws. And we've been pretty successful at it. So even things with like weather, we create structures, we create protection from that type of weather so that we're not as affected by it as other types of animals. Epidemics, diseases, we're still kind of susceptible to that. However, because of our modern medicine, we've been able to fight a lot of these outbreaks, these epidemics, because of sanitation and modern medical breakthroughs. The last one is probably the one that is the most important for humans, is the way that we have changed food production. We've changed over time from hunters and gatherers to now we end up producing large amounts of our own food by farming. Food production has changed. We've really made it into an industry where we create large amounts of food in relatively small areas. Now, on the surface, that doesn't seem like it's a problem, but what can happen is that can have us expand outside what the earth can normally carry. So we keep growing and our population keeps increasing, but the concern is that we may end up getting some very serious consequences because the human population may get too high. So in worst case scenario, you're talking about extinction of the human race. If you have too many individuals fighting over these resources, eventually everybody's going to get not enough resources, and so virtually everyone dies out. The increased human population creates more pollution, and so we have lots and lots of issues with mainly air pollution, but there's also water pollution, soil pollution, lots of issues. And the one that is probably in the news the most right now is climate disturbances. So climate change has become much more in the news in the last few years, and that is a direct or has a direct connection to human population. So, those are all very real concerns and problems that we're facing, all related directly to the human population issue. And we're going to come back to that later, and we're going to talk about, what other impacts, out of all the topics that we talk about this semester, human population is probably the single most important variable. Everything that we talk about, the chemicals that we use, the food that we're producing, all of this goes back to having a very, very large human population. And so if we had a smaller human population, then it would solve a lot of these problems. However, on the other side of that, it's very easy to say, oh, well, let's just decrease the human population. Well, how do you do that? Who is going to be told, oh, you can't have children? So you come into some other, ethical questions and, realistic questions regarding governments about how to decrease that. You hear about the one-child policy in China, which has now ended. But for a long time, that was the policy, and there's a lot of pushback for that. So, imagine trying to take the entire planet essentially and say, okay, every family gets one child. There's going to be a lot of consequences for that. So, I'm not sure that's a realistic option. Okay, so probably the biggest idea that we can take away from what we've been discussing is biodiversity is very important. We've already talked about biodiversity quite a bit, but the more biodiversity there is in an ecosystem, usually the more stable it is. So there are a lot of variables that affect stability of ecosystems, but usually biodiversity and stability of an ecosystem do have a very linear relationship. So as we're talking about populations and the way that they change and the ability to survive, the thing that really allows individuals, or really populations, not just individuals, to survive is the concept of evolution. And if we break down evolution to what it really is, and I don't want to spend a lot of time talking about the nuts and bolts of evolution because we've already done that in the introductory biology class, but in this course, what I really want to focus on is what happens in evolution to help these organisms stay alive. Evolution is a life-sustaining process, so they make adaptations that help them outcompete or hide from or hunt other organisms, really just to stay alive. I mean, we know what things you need to do in order to stay alive, so evolution just helps them meet that. Whoever is best at staying alive is the one who reproduces, and their genes end up getting passed to the next generation. So below my picture here is a kind of rough tree, family tree of evolution. Is definitely not complete, but just kind of gives an overall picture of some of the relationships. But you have to keep in mind that each organism on this family tree survives because of the adaptations that it possesses. So these changes, these differences amongst organisms really help it survive. And so you have to think that this is going on over millions of years. And so these organisms take long periods of time in order to be the best fit for an ecosystem. Most of what we know about evolution does come from fossils, and so that's an important piece of information to keep in mind. But we can also look at organisms that exist today and see how are they using these adaptations. And we're going to use this as we get into your activity that you're going to be working on. Okay, so quick review of what evolution is. Genetic variation is the raw material for evolution. Without that, you don't get any changes, so we have to have genetic variation. Nature's editor is natural selection, so whoever is the best fit for that particular ecosystem for whatever reason. And keep in mind, that can mean a lot of different things. It doesn't mean that they're the smartest. It doesn't mean that they're the fastest. It just means they're the ones who were able to survive and have children. It's a very simple explanation. It doesn't mean that they're like I said, not the smartest. They're not necessarily the fastest. They're not necessarily the strongest. It just means that they were able to survive and somebody was willing to have children with them. Okay. Again, we're not going to go into a lot of detail about it because we've done this in introductory biology, but looking at how new species form, so you have a lot of small changes that add up over time. That's how we get speciation. Now, the last section here, the coevolution and ecosystem balance, is probably the one that's most relevant to what we're talking about. Organisms can evolve with each other. Sorry, I'm waking up my children, so I had to have a change of venue here, so I apologize for that. Where we left off is talking about coevolution and how ecosystems balance out. And so there's this thing where if one organism evolves, another organism can evolve with it. So, for example, looking at, let's say, hummingbirds. Okay, the hummingbird's beak is very well suited for getting nectar from these very long, trumpeted types of flowers. So it probably didn't just happen overnight. These two things probably changed together for whatever reason, but they changed together. So as one started to get longer, I'm assuming that as the flowers started to become deeper and trumpet out more, that only the hummingbirds whose beaks were long enough to reach down and reach that nectar, they're the ones who were able to survive and pass their genes on to the next generation. So that's just a very common example of coevolution, where one organism evolves and another organism evolves with it. Okay, one of the things that we need to take a look at is how are humans impacting ecosystems. So we know that our population is a big variable that affects whether or not or how we are impacting ecosystems, and that's what I asked you to take a look at, looking at the dead zone. How are we directly impacting some of these ecosystems? But we can look at it on a bigger scale as well. There's a lot of non-living things that we do that impact a lot of different ecosystems, and one of the biggest ecosystems around is the ocean. And so where that pollution comes from still always comes back to us, or very frequently comes back to us. And you can see some of these are really kind of odd. So one of those is, looking at this, is just sewage. You're talking about bathrooms. What's being flushed down the toilet is ending up in the ocean. So that's a major concern. So that's something that, as human activities, because there are so many humans, that waste has to go somewhere. And so an easy place for many, especially developing countries, it's not always the case, but there are some developed countries that have some old pipe systems. I was reading about a town in, I believe, Washington State, that's how its sewer system until recently, like the late 90s, that it was working, is that when you flushed your toilet, it would go right into the ocean. So that's kind of an extreme case, but in a lot of developing countries, that is what happens, is that there's nowhere else to go, so you dump it into the ocean. Farm runoff. Well, we were just talking about that regarding the dead zone. This is a major issue, and farm runoff has a lot of chemicals in it that impact living things. Air pollutants. We don't think about that being an issue, but what's in the air ends up in the water. So if there's air pollution, that's going to end up in the water as well, and so that is another issue for us. And look at these last three. Maritime transportation, so this is just coming directly from boats. Industrial wastewater, that's another big one. Companies that run right next to the ocean may take some of their waste and just dump it right in the ocean. It's an easy way to get rid of it. It's kind of like, oh, it'll dilute out, it'll be fine. But it really is a problem for us. Okay, and so this ends up adding up. We can take a look, and I'm not going to go through all of this, but sources of air pollution. The biggest one is industry. And depending on what pollutants are being provided, they can have different impacts on ecosystems. One of the biggest ones, and my plan is to talk about this a little bit more in the future, DDT. DDT is probably the most influential chemical in human history, the most influential man-made chemical in human history, and I'm going to guess that most of you are probably not familiar with it just because of your age. It's been outlawed for a number of decades now. We don't use it in the U.S. It's very limited in other countries, but it did a lot of different things. It was used to kill organisms, which we thought was a good thing at the time, but it ended up causing a lot of long-term problems. I talked about the other day at the beginning of class, looking at the impact of DDT on predatory birds. So there's a lot of issues that become involved here. So we could spend a whole semester just talking about the chemicals, but we're not going to end up doing that. What we do frequently do is we disrupt habitats on a regular basis. And we do that by taking what was there, taking nature, and then changing it. So we add our homes with our very well manicured lawns, and we build highways through areas, which then fractures these places, because if you can't tell, highways are a very difficult place for many animals to cross. And you might think, oh, well, highways aren't that big. Well, that's true, but if you're a turtle, getting across a highway is a major feat. So now you have just fractured this into two very separate areas. We introduce foreign species either intentionally or unintentionally. Sometimes they just hitch a ride. So because we have a worldwide economy, if I ship something from one part of the world to another part of the world, there may accidentally be some insects on that. Sometimes it's intentional. Looking at some of the beetles, so the Japanese beetle that we have around in Iowa and really is all over the Midwest. That was a foreign species. It is of Asian origin, but it was introduced intentionally. And the reason for that introduction was because they wanted to eat the aphids, because the aphids were a nuisance to some of these plants. Well, if you can't tell, those Japanese beetles are now their own nuisance. They don't have any natural predators, so they just grow completely, out without any controls. We don't have that predatory system to keep them in check the way that we have with a lot of other ecosystem organisms. The emerald ash borer, that was not one that was introduced intentionally, but as we know, it's now in Iowa. It's crossed over. It's in, I think the last I heard, it's in 30 counties in Iowa. Is basically wiping out ash trees. Again, it is of Asian origin, but it was accidentally introduced. One of the other things that we do by tampering with biotic factors is we've essentially eliminated predators. Now, sometimes that's for good reasons, sometimes it's accidental, but one of the major examples that I always recognize is everybody complains about the number of deer in Iowa, saying, oh, there's too many deer. Well, we've eliminated the major predators for deer. There are no mountain lions. Mountain lions would have been plentiful in Iowa at one point, but now we basically got rid of them. And now if anybody sees a mountain lion, they go out and they kill it, even though there's really not a huge risk. Mountain lions don't see humans as food sources. They generally don't attack humans unless they have no other option. So it's these people who are going out and really actively hunting the mountain lions who are putting themselves at risk. So if we allowed more mountain lions, there'd probably be fewer deer running around, fewer car accidents, less damage to crops, things like that. But then you have this issue of, oh, well, there's more mountain lions, but we also have a lot of homes in those areas, so we don't want that mix. Like, I don't think most people are opposed to having mountain lions. They just don't want mountain lions around people, but people are everywhere, so we end up having this kind of catch-22. We sometimes introduce diseases, either intentionally or unintentionally. There's lots of different examples. So killer bees, that was an unintentional release of a hybrid species. They escaped, but now we can't control them. They just have bred out of control. They don't have a whole lot of natural predators. Lots of examples. One of my favorites is the kudzu vine. Again, Asian, and I keep saying all these Asian examples, but it's not, it's not that, Asian plants are that much, more controversial, or that Asian plants or animals or insects are, like super organisms. It's just the habitat, the ecosystems they're from are so different from the ecosystems we have here in North America. So there are no natural predators. Northern Europe is much more similar to the upper Midwest. So if an organism was introduced from Northern Europe, it can fit in a lot better in the upper Midwest than, say, something from Asia. Anyway, the kudzu vine is a great example of us introducing a biotic factor. It was brought in mostly into southern states to help control erosion, and as that happened, what they did is they planted this kudzu vine, and it would grow very, very quickly. However, they didn't realize how quickly it would grow. The ecosystem that it was in allowed it to grow very fast. It would overtake entire cars or buildings. I saw a picture, a time-lapse camera, showing an abandoned car being covered with kudzu vine within a couple of weeks. It was completely engulfed. So it's kind of crazy. Again, there's no natural predators. So this loss of biodiversity makes ecosystems harder to survive. But again, we do this. We simplify these ecosystems all the time. So we convert forests into farmlands. We plow them under, and then we plant a single type of crop. And we're going to talk about that more when we get into the agricultural system. But the field becomes very simplified because there is only one type of plant there. And that's not how ecosystems work. You don't usually have a single crop. You don't usually have a single type of organism there. You have a number of different organisms that are all working together to help it be successful. So monocultures have a lot of problems, and they very often can have pests. And those pests need to be controlled, and so we spray things like pesticides on them in order to kill those. All right, so that kind of wraps up the main idea here. What I am going to ask you to do, and I'm going to post this on Schoology, is I want you to take some of these ideas, and I'm going to ask you to create another project. Okay, and here's what your task is. I am asking you to sell a product. Okay, and I have a descriptor on Schoology, so you'll be able to see this. But what I'm asking you to do is do a little bit of research and look at how certain organisms are adapted very, very well for an ecosystem. Now, as humans, a lot of times we try to override nature and say, okay, we can do it better than nature. But we have to keep in mind that these things have developed over sometimes millions of years, or tens or hundreds of millions of years. And so they're very well adapted, and they do a great job. And so we're not just going to make something that does a better job overnight. So instead of just trying to overcome nature and do our own thing, maybe we can use nature in order to solve some of our problems. So what I'm asking you to do is mimic something that happens in nature and either create or research a product that is made that is based off of something in nature, and determine how it would be beneficial. Okay, and the major example that I use, so sorry about that. I wanted to open up a new page and show an example. I think the Biomimicry Institute is a great resource for this. And one of the examples that I frequently use is this Shinkansen bullet train in Japan. So I'm going to summarize the story. If you want to read more about it, please feel free to do that. But I'm going to kind of summarize it. So this train Japan is a very mountainous area, so this train's going through essentially tunnels in the mountains, but it's going over 200 miles per hour. So as it goes through these tunnels, the air becomes very compressed and it makes a popping sound as it goes through. Now, this popping sound was disturbing people who lived near the railroad tracks. It would break windows. It was a pretty serious issue. So what they did is they said, all right, we need to stop this, because essentially what's happening is we are taking a high pressured air and then allowing it to depressurize very, very quickly. So we're going from one substance into another substance. So what they did is they took a look at nature and said, okay, what's an organism that does that, where it goes from a very dense or one type of medium and travels into a different type of medium. And one of the examples they used was a kingfisher. Okay, and so those of you who are not familiar with kingfishers, they get their name because they are birds, they fly, they dive into the water, and that's how they catch their prey. They catch fish as they dive into the water. So they're going from a very, very loose, low density medium, air, and going into a much more dense medium, which would be water, and they do it without much of a splash. And so the front of these trains are modeled after these kingfishers so that it can go in and out of these tunnels much more efficiently. And so there was a lot of benefit to this, and I'll let you read some of that. So if you go to biomimicry.org, there are several other examples on here if you want to take a look at those. But this was just one that I think is one of the best examples because it made the trains much more efficient, and they're just mimicking what has happened over millions of years in nature, that, you know, it solved this problem, and all we have to do is look to nature in order to solve it as well. Okay, so that's what I'm asking you to do, is pick a product, and you could choose any one of these products, or maybe you want to choose something else that isn't on this page, but pick a product and then talk about what the benefits are. You're trying to sell this item, so you're essentially making a sales pitch. Okay, so you are trying to sell this item to someone else. You're trying to make money off of it. So if you're going to do that, then you want to be talking about what are the benefits, what makes this a good product, some of those items. So I'll leave you with that. If you have questions, email me. I apologize, I won't be at school today, so you won't be able to ask me any questions about it. But other than that, I will leave you to it, and I'm sure that you'll do a great job. So have a good one, and I will see you soon.